Okay, so next, why applications are operating systems specific. Okay, now on this slide, what is said here is that once you have created a program in Windows, it should be running only on Windows. All right. So once you have created a program in Mac OS, okay, it should be running on Mac OS. Okay. So apps compiled on one system usually not executable on the other operating systems. So each operating system provides its own unique system calls. Okay. So from the previous slides, okay, we have shown some of the differences between the Windows and the Unix system calls. Okay. So when we created a code for Windows, of course, you cannot run that for Unix because the system calls that you used in Windows is for Windows only. Okay. So apps can be multi-operating systems. So written in interpreted language like Python, Ruby, all right, and interpreter available on multiple operating systems. So that's the time we could have an application or an apps that is running in different platforms. Okay, so app written in language that includes a VM containing the running app like Java. Okay, so Java can run in any platform, right? So use standard language like C, compile separately on an operating system to run on it. Okay, so we have what you call an application binary interface or ABI. This is an architecture equivalent of API. So defines how different components of binary code can interface for a given operating systems on a given architecture, CPU, etc. All right. Okay. Next is design and implementation. Okay. So design goals, basically requirements define properties which the finished system must have and are necessary first step in designing any large complex systems. Okay, so there is what you call a user requirement. Okay, so user requirements are features that users care about and understand and are written in commonly understood vernacular. So they generally do not include any implementation details and are written similar to the product descriptions. So one might find a sales brochure or outside a shrink wrapped box. Okay, that's user requirements. Okay, that's very important. Next is system requirements or system goals there. Okay, so system goals, these are written for developers and include more details about implementation specifics, performance requirements, compatibility constraints, standard compliance, etc. So these requirements serve as a contract between the customer and the developer, okay, and between developers and subcontractors maybe, okay, and it can get quite detailed. All right, so you'll have design and implementations, okay, so user goals and system goals, or in some textbook they use user requirements and system requirements. Okay, so requirements for operating systems can vary greatly depending on the planned scope and usage of the system. So single user, multi-user, a specialized system, general purpose, high or low security, performance needs, operating systems environment, etc. All right. Next, how about the mechanisms and policies here? Okay, so policies or policy determine what is to be done, while mechanism, all right, mechanism determine how is it to be implemented. Okay, so if properly separated and implemented, policy changes can be easily adjusted without rewriting the code. So by just adjusting parameters or possibly loading new data on configuration files. All right. So for example, the relative priority of background versus the foreground tasks. Okay. When you say background, these are the applications running. Okay. Without without the users getting or without the users noticing it. All right. So these are the applications running at the background. or this is usually associated with operating systems. All right? Okay, so next is implementation. So traditionally, all right, OSS were written in assembly language. So this provides direct control over hardware-related issues, but inextricably tied a particular OS to a particular hardware platform. Okay? So recent advances in compiler efficiencies mean that most modern OSs are written in C, and more recently C++. All right, so C or C++ is not obsolete yet. Okay, so in the industry, these are mostly used on the background programming, okay, or back-end programming. All right, so critical sections of code are still written in assembly language or in C, compiled to assembly, and then fine-tuned and optimized by hand from there. Okay, so operating systems may be developed using emulators of the target hardware, particularly if the real hardware is unavailable or not built yet. Right, so we are using this emulation software. Okay, so or not suitable platforms for development, example smartphones, game consoles, and other similar devices. Okay, the emulation or the emulator, as they call it, can allow an OS to run on a non-native hardware. All right.